My name is Maxwell Ramstead. I'm currently a postdoctoral fellow at the Jewish General Hospital in Montreal, and I'll be staying at McGill for a while. Yeah, I'm also affiliated with McGill University, which is the main university affiliation of the hospital, and I'll be a postdoc in the Department of Psychiatry at McGill starting next September. Yeah, so basically my background is in philosophy and cognitive science, with some additional training in computational neuroscience. Yeah, so currently I work on basically multi-scale active inference. So multi-scale extensions of applications of the free energy principle to basically like systems beyond the brain. So like systems well, within and beyond the brain, right? So what I'm interested in developing is kind of a multi-scale approach to cognitive systems. And that's how I got into the free energy principle originally. So I started off more interested in this field called Neuro Phenomenology, right? So like the kind of so phenomenology is a philosophical discipline originally, and it's about the kind of rigorous description of first-person experience. So neurophenomenology was a project. It's still ongoing in part. A project to bring together this rigorous description of first-person lived experience with the neurosciences and other sciences that might tell us something about how experience comes about, like first-person lived experience. Yeah, so I was working on that for a while, and I was looking for a way to talk about what I think is like a really central intuition, which is that like all of the different levels of description of reality are like they have some grip in a way that's like there's an equal dignity to all these different descriptive levels. So like, we are physical systems, right? We're made of atoms. So the laws of the regularities that pertain to the physical world apply to us, but we're also biological creatures. We're made of cells, right? And we have a psychology, right? And we conglomerate in social groups that have, social and cultural scripts. And so we also have like a rich, infinitely ramifying first person experience. And somehow all of these things are true at the same time, right? So how can we develop a framework that addresses all of these levels, yeah, with equal dignity, with taking each seriously. And so, around 2014, I was looking for a kind of glue that would allow me to kind of talk rigorously about all these levels at the same time. And I met Carl Friston basically, and so the rest is kind of history. It really started me off on my current path, and yeah, right now I work with Carl very closely.
And who is Carl?
Carl Friston.
Yeah, but what's his significance
right.
in this picture?
Yeah, right. So Carl Friston is I think right now the most cited living neuroscientist. He's known in the field. I mean, for several different reasons. What his probably most lasting contribution is, well, so far, has been the development of basically the statistical packages that allow us to perform neuroimaging analysis in the Fmri modality. So in the 90s, he basically invented statistical parametric mapping. Yeah, which is the main technique used in neuroscience.
So is that like taking the data and it's like something that enables you to like interpret the data or actually make sense of it? Like having the data is one thing, but actually be able to derive insights.
The whole framework that I'm going to be explaining, it's very complicated. It looks very complicated, but conceptually it's very simple. You can explain it with two circles and a line, I like to say. Right, so the two circles are data, right, that you have, so observations, states that you can observe or measure, and latent or hidden states that caused your data, right? So, I mean, to just start with the beginning, I guess. So, you know, are you familiar with fMRI neuroimaging? So fMRI
Somewhat,
is
yeah.
functional magnetic neuro, yeah. Basically an fMRI machine is a big magnet, and you put people in this big machine, and it measures the signal that it measures is called the BOLD signal. It's the blood oxygenation level dependence signal. So this is something to keep in mind whenever you see neuro studies in general. Typically, you're not directly measuring brain activity. So these heat maps of brain activity that you see are not directly measuring brain activity. You're always measuring a proxy for brain activity, right? So in fMRI, that proxy is the BOLD signal, this blood oxygenation level dependence signal. So basically, one of the metabolic byproducts of neural activity has these interesting magnetic properties that we can pick up using these big magnets, right? So you put someone in a big magnet, and then you scan their brain using the magnet, and essentially you're picking up a byproduct of oxygen consumption by the brain. So then that's your data. And then what you do using these statistical techniques that Carl and colleagues developed is work backwards from this data to basically the most probable set of hidden causal factors that generated your data. Yeah, so he came up with this in the 90s and continued extending these methods. So I mean, the idea here is always sort of the same, right? So what you're doing is you're writing down different alternative causal structures or models of the causal structure of the process that generated your data, right? So these techniques have been extended recently, and in principle, you can model any kind of data using these kind of techniques. So recently, Carl has used like the newest version of these frameworks, dynamical causal modeling, to model the spread of COVID as it happens. So in this case, like the data that you're using is the raw numbers, like so the total number of cases, total number of deaths, and the causal process that you're estimating is stuff like, you know, is there confinement? What is the population size? Like all of these different parameters in your model that you're estimating given your data. So that's basically like the kind of general framework that he developed. Active inference per se gets into the game when you take the same kind of framework and say, okay, what does it look like when the data that I'm trying to explain isn't like neuroimaging data, but it's the actual sensory data that I'm generating as an organism? Like, yeah, so that's active inference in a nutshell. It's a framework to that extends these modeling techniques in a way that it's sort of like, what would it look like if the organisms themselves leveraged these strategies to effectively infer the latent causes of their sensory states?
So active inference is something that organisms do, but it's not the technique used to measure the sensory data, but it's something that organisms do. Like we actively infer.
If the framework is correct, so you can think of the active inference framework as this mathematical theoretical apparatus that we're applying to biological systems to understand them. But on the assumption that the framework is correct, yeah, active inference is something that living systems engage in. Basically, this kind of, so active inference essentially has two sides, right? On the one hand, you're trying to infer which kind of constellation of causal factors is currently causing my sensory phenomenology, right? So yeah, that's on the one hand. And on the other, and this is like a crucial point, active inference is about, so this is what makes it different from like older Bayesian theories, like predictive coding, for example. It's a theory of active sampling of the world. So it's not merely a question of like Bayes optimal perception. It's a question of how do I act such that I bring about my preferred observations.
Yep. So it's like this tie between the entity acting within the environment, taking its sensory input, trying to understand or identifying what's actually causing what. So it's like this interplay between sensory experience and action, and that's why.
Yeah, essentially, yeah.
Yeah.
Yeah, it's a formal model of the sensory motor loop is another way to think about it.
Okay, cool. So the free energy principle. So Carl Friston, what's the relationship between, there's a few ways I want to go about this conversation, because I want to talk about cognition and information processing. And I also want to talk about, I mean, the purpose of this podcast is really find out what the hell the free energy principle is, and like, what are its applications and how does it actually work? Because in other podcasts, like I came across the idea and I've just been like very excited about it. And like a few of the podcasts that I've had, I'm just like, oh yeah, this thing kind of applies here. And I just kind of give a half-baked description of it, which is one of the reasons why I want to talk to you, just so I actually know what the hell I'm talking about. So do you think it would make more sense to kind of discuss cognition and information processing and dive deeper into active inference, or just start with the free energy principle and go from there? What do you think makes better introduction?
Maybe I can show you a few slides.
If we can describe the slides as well, just because there will be many of those who'll be listening.
Yeah, absolutely, 100%. Yeah. Let me just pull them up. Just to give you, I mean, it's really just to be able to see it at the same time. So for those of you who will be listening the podcast without any visual support, it's really just the two circles and the line thing that I was discussing earlier. But it's good. It's often useful to see. I'm a visual person anyway. I don't know about you, but I find it helpful. Okay, so.
Yeah, if anyone wants to check out the YouTube video or just photos, I'll like all of the photos and links.
You're gonna have to enable screen sharing on my end.
Oh, yep. Bloody Zoom. There we are.
All right.
All these privacy features.
All right. So this is a kind of cartoon tutorial. So this is what I was saying earlier, right? Two circles and a line. So what you have is you have data, right? Observable states that you have access to. So again, like if you're working in Fmri, for example, your data is your bold signal. And what we're trying to do is basically go the opposite direction here, right? So causality flows from hidden states to data. You can also think of prediction as going in this way, right? So like if you have a model of how some phenomenon it works, you can predict that you'll be generating this kind of data rather than that kind of data, right? So that's sort of the point of being able to use these predictive models. I mean, you see this a lot with the COVID modeling, right? People have a model of how the process, the propagation process happens, and so that they kind of can project the kinds of, data that they will be registering in the future, right? So causality or prediction moves in this direction and inference moves in that direction. So these hidden states or latent causes that are generating our data, what we do is we write a model, right, of basically the relations between the factors such that they generate the outcome of interest, right? And the variational free energy, I think the easiest way to think about it is that it's a measure, or more precisely an approximation of how much evidence we have for a model given the data, right? So like you can think of, I don't know, like say 2 or 3 alternative models of how some data was generated, right? And the free energy is basically a model of how, a measure of how well each of the models explains the data. Like, so how much of the variance, for example, you're
so
explaining?
When you say explains, you don't mean, do you mean actually explains why it happens, or predicts what's going to happen? Like, it's not an explanation of how X causes A causes B, but it's like a predictive thing.
Explanation. If we're gonna like draw from the philosophical literature and talk about like models of explanation. So if you're thinking about mechanistic explanation, there are a few missing elements here. But basically, like what you're doing is saying, well, given the data that I have, which of these models is most probable, given given the observations that I've made, which of these models is most probable? And the free energy is essentially a metric or a measure of that the amount of evidence that the data makes available for each of the different models.
Sorry, I'll let you continue.
Yeah, so I mean, this is the Fmri setup that I was discussing earlier, right? So you have a bold signal, you have hidden causes, which in this case are the underlying neurobiological activity. And what you're doing is essentially constructing alternative models of, for example, brain structure or connectivity, right? And then scoring how well each of those models, alternative models, explains the data that you're generating, with the assumption that like the model that, so it's a kind of, it's an abductive kind of or inference to the best explanation kind of framework, where what you're saying is, well, you know, the model that most probably describes the actual causal process that generated my data is the one associated with the most evidence. Yeah, so so transposing exactly the same reasoning to the brain, you have this kind of setup, active inference per se, where the data that I'm trying to explain is the sensory states of my organism, right? So like the states of my retina, right? The states of like my auditory organs, like my cochlea and all that, like the state of my you know, receptor cells in my skin. And the model here isn't the model of I mean, at some stage it might be, but like the model is ultimately a model of the agent acting in the world. Since our actions are the main driver of our sensory phenomenology. Yeah, so in a nutshell, that's kind of the framework. And in all these cases, the free energy is basically a measure of evidence.
Yeah. So I've got two questions. One, I think I'll just put to you my layman's understanding of it, and I want you to tell me if I'm right or wrong. And then after that, I want to know, why is it called, why is free energy the measure? Like why that term? So the way I sort of see it, and I think I've described it to friends, is that organisms have a model of, they have an internal model of themselves and the world in which they inhabit. And they try to act in the world in such a way to minimize uncertainty or surprise. And this is kind of the mechanism by which it happens, or this is like the description of it.
Right.
That you've just been
I would
speaking
nuance
about.
that a bit and say that the free energy principle tells you not just that you have a model, but that you are a model, right? So in the sense that, like, it's not like you carry around, I mean, to a certain extent you do, right? Like there is something like a model in the brain, right? Like it's not quite that. I mean, what we would prefer to say, I think, is that like the brain embodies parameters of a model, but the whole model is something like the brain's inference activity. So look, to think of it this way, like this issue of model has to do with predictability, right? So what does it mean to say that I'm a model of my environment? Well, so look, we're having this conversation, I'm wearing a sweater, right? So you can tell from my wearing a sweater, or you can predict from my wearing a sweater that it must be 20 degrees Celsius roughly in my room. Maybe a bit less, maybe 15, right? Because it's a sweater. It's not like a t-shirt. So there are these like systematic relationships between the organism's phenotype, right, and the state of the environment. These are predictive relationships, essentially. So that's the sense in which you can say that the organism is a statistical model of its environment. It's that, so like the physiology of the fish tells you something about the kind of environment that it lives in. So the fish is a statistical model of an underwater environment, right? So and the fish's phenotype, it becomes extremely unlikely on land, right? Just like I would be very surprised to find myself in water all of a sudden. So that's the intuitive notion there. It's not just that, and this is where it departs from older classical like cognitivist theories to an extent. I mean, in my view, it kind of vindicates, you know, classical cognitivist ideas through the lens of these new cool like embodied and active kind of stories. But yeah, like on the classical story, like I reconstruct an internal model in my head, and that guides my action. So that story is still here in part. I mean, you know, clearly, as human organisms, we do construct these explicit internal models that we manipulate, and they're the same kinds of models. But there's like a broader notion at play here. It's not just that I have a model; it's that I am a model, and a really strong.
Okay. Okay. You said inactive and embodied, and like I jumped on Twitter maybe last year, and I keep seeing, you know, inactivism and embodied cognition popping up more and more. And I spoke to Lisa Feldman Barrett a while back, who's
she's great. She's
yeah.
Well, I think she's
and this kind of reading her book, How Emotions Are Made, I think it's called, just blew my mind, completely changed my worldview. And I guess
it's a very powerful point of view that she's defending. I mean, I'm very, very, very friendly to the kind of constructivist view of emotion that's being pushed by that group. It's very,
and I guess just for those who are unfamiliar, and Maxwell, if I, you know, don't do it justice, please jump in. But what I took away from it was like we have all these underlying bodily sensations that we interpret and then give meaning to in a way. And, you know, it could be, we may feel a gnawing in the stomach and we may interpret that as hunger, or it could actually be anxiety. And like we construct the emotion from that. And something, and this ties into what we're talking about here through active inference, that emotions, in a way, I think what did I write down? Yeah, emotions are like an emergent form of prediction, and they're like how we at this scale of this organism, how we predict what's going on in the world and then react to it, right? And like emotions arise based on sometimes the mismatch of our prediction and the actual result.
Yeah, precisely. I mean, we have a preprint that's in revision right now in neural computation, where we make basically that kind of argument, which is to say that, well, myself and our co-authors, Casper Hess, who I collaborate with very closely, Ryan Smith is also on the paper. These are all like very cool researchers. Casper is probably the person I've been collaborating with the most recently. He has a background in computational astrophysics. Oh, I am still sharing my screen. Sorry. So the paper is called Deeply Felt Affect. So also on the paper is Thomas Parr, who is basically a genius. I mean, Thomas is like one of the most impressive scholars that I know. He's Carl's right-hand man, basically. And Micah Allen is also on the paper, and myself. Micah is a cool interoception researcher. He does very cool stuff as well. You might want to check out his research. But yeah, so Casper, Ryan, Thomas, myself, and Carl are on this paper, and what we're essentially arguing is that you can think of emotion by unpacking it formally in terms of basically state inference about your state inferences. So like higher level inferences about how well you're doing with your lower level inference stuff. So we're sort of saying that emotion arises along with kind of implicit metacognition, that as soon as you start to monitor yourself and to assess how well you're doing, implicitly you're moving towards like emotional types of inference. Where like, yeah. So I mean, to keep it simple in a nutshell, that's what we're arguing in that paper.
Yeah.
So.
Well, what's really exciting about this perspective is that it brings, like, you know, we used to, like, some people think of emotions as just like these useless relics or of our animalian past, right? That they have absolutely no function, and that if we were rational, we would do away with emotion. But I guess from this perspective, it's like it's vitally important to how we interact with the world. And it's like, it's this, you could say like this compass of sorts that has emerged over time. And it's actually highly attuned to, ourselves and our place in the world. And that without these things, without these feelings, that we would just be bereft of any navigational means. We just wouldn't be able to survive.
Exactly. 100%. And I mean, so we were talking about like embodied and inactive. So like all these
break down those, if you could break those down in some way.
So typically what you'll hear about is the 4EA approach, right? So the 4 E's are extended, embedded, embodied, and inactive, and the A is affective. So we just covered the A, right? And so all of these perspectives are meant to be correctives or criticisms of the traditional kind of cognitivist framework. Susan Hurley calls this the cognitive sandwich, right? Where you have perception, cognition, and action, right? In that sequence. So perception is basically like taking in passively the world. Cognition is creating an internal model that you use to that you manipulate to make sense of the world and then use to plan action. And then action is seen as sort of the motor output of this kind of process. So the cognitive sandwich, right?
Yeah.
So the 4EA approach says this is wrong for several reasons. So we just discussed the A reason that it's wrong, right? Cognition isn't just like this kind of flat calculating process, right? It essentially involves self-monitoring, self-appraisal, the emotional reactions, right? So the E's are also correctives of this cognitivist perspective, right? So I guess the 2 E's that kind of come together are embedded and extended, which are basically like one more and one less radical version of the same claim. So to illustrate it, I'll give you an anecdote. Richard Feynman the famous physicist, right? Who was involved with the Manhattan Project. He's one of my idols. I love the man. He's just amazing. So Feynman was talking to this man who had bought the notes that where he jotted down like a famous equation, like the original kind of notes where he worked out his equations. And he said, look, I have a trace of, your thinking. And Feynman responds, no, what you have is my thinking. It's not just like a trace or like a testimony of my thinking. I used those equations to think through on the paper, right? So this comes together under the broad rubric of embedded and extended cognition. So the idea that like cognition is something that is essentially world involving. It's not just like cognition is something that's in the head, and sometimes in some context it spills out into the world in interesting ways. It always already involves engagement with the world. And then, the differences in metaphysics, like if you want to say that the world literally becomes part of the cognitive system as this kind of cognitive overspill happens, like, if you literally want to say that when you're writing an equation on a blackboard, the blackboard becomes part of your mind, then you're in the extended mind camp.
Yeah.
So the mind is literally extending.
Yeah.
One possible metaphysical inconvenience of this view, though, is that it means that like when you're using Google to perform a query for a few seconds, or whatever fraction of a second it is, like the servers are actually part of your cognitive processing. Some people want to avoid that implication, and
I just want to jump in. Is mind synonymous, or like what's the connection between mind and cognition here? Because I mean, I think of cognition as information processing, whereas mind is very different, right? Like mind is this subjective experience.
That's a nuance in the literature. Some people, I think people will more safely talk about extended cognition.
Yeah.
That's a pretty safer view, right?
To think that Google's just got a part of my brain, and that like my mind is in Google is a little bit crazy.
Yeah. So it is safer indeed from a metaphysical point of view to talk about extended cognition, all right, rather than the extended mind. I think the thesis is used interchangeably, like the label for the thesis. Although you're right, like that is Andy Clark, I think, discusses the nuance. He's one of the people who's worked on this a lot. I mean, the original paper, I think, isn't it from Clark and Chalmers? Yeah, it's,
I don't know.
just let me make sure. Clark, Chalmers, The Extended Mind. Yeah, exactly. It's Andy Clark and David Chalmers are the people who kind of originally proposed, at least the contemporary version of this. Yeah, and Andy has this great book, Supersizing the Mind, which kind of takes the idea and runs with it. Yeah, but so I think some people would want to say, yeah, it literally is the mind that's being extended. Some people want to say, no, it's just cognition. But you could also think that this is a bit of a wacky idea and want to recognize that, like, there's a situated aspect, an ecological aspect to cognition, without buying that cognitive processes actually extend beyond the skull.
By
So this kind of
ecological, do you mean like we are embedded within some environment, and that?
Yeah, precisely. And
the
the view is
interactions.
called the embedded mind.
Yeah. Okay.
Extended and embedded. Embedded is like the less radical cousin of extended.
Okay.
It kind of eschews the whole, like, metaphysics of, does the mind extend? Does it make sense to say that cognitive processes spill out? And says, well, clearly, to get some kind of ecologically valid behavior in humans, cognition needs to be scaffolded or embedded in the right kinds of contexts. So I mean, you know, for some people who don't like the radicality, I'm not one of those. I want something more radical personally, but yeah, that option does exist though in the literature.
So how do you think of cognition? Like, what is cognition, and how is it different to information processing? I mean, I'm sure they're very, very similar, but like, when does a form of information processing become cognition?
So,
or is that the right question?
I'm not sure. I'm not sure anymore. I mean,
because by talking about, you know, like if through this lens, if I'm writing equations on a blackboard, or like typing into my computer, or, you know, interacting with, I don't know, Wolfram Alpha or something, and that's performing, that's processing information on my behalf. When does that become cognition? And if it is cognition, then are all my cells, because they all process information, my immune system is processing information, like my whole body is processing information at all times, like our individual cells.
If I had to, I'm sort of, I don't really like these broad concepts like life, cognition. No, but I mean, I suspect that it's the kind of thing that breaks down when you look at, like, the kind of border cases. I had when I was an undergrad, like a decade ago, like I had a philosophy of biology professor who was an eliminationist about life, Frédéric Bouchard at University of Montreal, and that kind of stayed with me. I think he says,
so
like,
what's an eliminationist?
Well, an eliminationist in general is someone who thinks that X or Y concept actually doesn't serve much of a purpose anymore and shouldn't be used scientifically. So a typical example of elimination in the progress of science is like the elemental fire of the ancients, right? So, you know, in ancient Greece or whatever, you know, there were these ontologies, these elemental ontologies, right? Where, like, the universe is, like, for Aristotle, like a combination of different elements, and, you know, there are similar versions of these ontologies, like, across cultures, like, you know, with different elements. Like, I think the Chinese elements are something like metal, wood, fire. You know, we don't have in the West, these ontologies didn't have metal, but whatever, you know. And so fire, under these ontological classifications, which were, I mean, you know, they were sort of scientific at the time. I mean, I don't know if it makes sense to project our modern understanding of scientific practice back onto the Greeks, but certainly they were using these concepts explanatorily, right? So, like, you know, Aristotle thought that things that were of the earth element fell to the ground. right? And that's why they fell to the ground, because they had an affinity to the ground because they were of the element earth, and inversely for flame, right?
Mm-hmm.
So for the ancients, fire the element fire was like the underlying kind of commonality and explanation for what we would regard today as very diverse phenomena, right? Like, so bioluminescence in little insects like fireflies, that was fire, right? Rapid oxidation of wood material in like a campfire was also fire, but the sun also, right? Which we know isn't fire. I mean, it's nuclear plasma, right? That was also fire. So the progress of science has showed us that, well, this concept that we were using doesn't actually have any explanatory grip. It names things that are heterogeneous in their mechanistic basis. And so similarly, one might argue, well, life is one of these concepts. Like, it seems to us at a kind of everyday macro level that there's a distinction between life and non-life. But is there? I mean, I don't know. And I've sort of started to think that these, like, working on these concepts per se is kind of hopeless. And so, like, I don't know if I want to give a blanket definition of something like cognition or life, precisely because I don't know if there's such a natural kind to begin with, right? I don't know if
yeah. Well, a lot of these categories or concepts are like, the way I think about it is there's just patterns that we interpret, right? And and we just give a label to some patterns, and, like, you know, all dogs have a certain, there's a certain pattern that they all have in common, but there's a lot of, like, just crap. There's a lot of noise that, like, doesn't actually correspond to what actually, you know, like a Chihuahua might seem more like a rat than a greyhound, for instance, but they're still dogs. So, like, I think of these concepts as just like approximations that are, like, good enough to enable us to work with them, right? Like, you can have an infinite number of concepts.
If you painted me in a corner, right, and you put a gun to my head and said, define cognition, I would say something like, it's information processing in the service of maintaining phenotypic integrity, right? In the service of keeping me alive. I mean, and so that's another angle into the free energy principle, by the way.
Yeah. Well, I want to come back to that. I just thought we'd kind of, like, go through these, because there's a lot to it, right? If we're just talking about entities or organisms, like, maintaining themselves or, like, trying to minimize surprise, there's the discussion of, like, how they actually do that, what they are, like, how, I mean, if we're talking about extended cognition or whatever it was, like, that's, if we really extend it out there, then what is actually being maintained? So I don't know where I was going with that, but if we were to bring it back to the free energy principle, and, like, in terms of just minimization of surprise, or these concepts
to discuss, though, for
sorry, that's right.
It's all right. You know, it's a lot to take in, and for, like, you know, for better or for worse, like, it all feeds into this. So it may be good to put all the okay. So we discussed affective, extended, and embedded. The two remaining E's are, I think, like, the most exciting, personally, the embodied and inactive. So the embodied mind is this idea that cognition isn't just in the head. Like, cognition isn't just accidentally something that's implemented in fleshy, like, wetware systems. Like, cognition, like, is premised on the existence of an embodied organism, and basically the embodied mind says something like, well, you need to appeal to the physical living body to explain a lot of what cognition is, right? So you can at least take this in, I think, 3 different ways. One would say, well, the physical body is co-constitutive of cognition. So, I mean, you may have seen these really depressing studies that were conducted on judges a few years ago,
like,
where
they, after lunch or something, they're just not as nice.
So for our listeners, basically what they do is they plot it. So it's a survey, it's a study of judges and their acquittal behavior. So, like, basically they plot your odds of being charged or acquitted against time of day. And so it seems that at the start of the day, you have a basically 80% chance to be acquitted. And as you approach lunchtime, it drops to 0%. And then there's a bump back up to 80% after lunch. So it seems, so that the way that the researchers interpreted this is that it has to do with blood sugar levels. Like when you have a lot of blood sugar available, you're ready to consider things like more deeply and really, and then when you're getting hungry, there's just no more glucose to do the activity, so you don't. So if someone wanted to say, well, you know, what cognition is just like rational, purely intellectual activity, well, I mean, you know, this is one of the demonstrations that isn't the case. I mean, it seems that the body essentially participates in cognition. And another example of this kind of physical embodiment and its relevance is like phototaxis in crickets is a very, very widely discussed example in the literature. So phototaxis is a behavior that the crickets basically orient themselves towards mates by exploiting the geometry of their bodies in picking up sound. So basically, to initiate an approach of a mate, a cricket uses just two neurons, and it basically computes which of the neurons is stimulated first, and it moves towards that one, because basically its ears are organized in such a way that the sound will hit one ear before the other. And so the actual information processing that the cricket accomplishes to orient itself towards mates exploits the physical geometry of its body. Like, rather than having to engage in a more complex computation, the actual layout does the computation for you. Human walking is very similar. I mean, if you pay attention to this too much, you might hurt yourself. But like, basically, walking, the human gait is falling forward and catching yourself with the next leg. So it is not the case, as some people would say, optimal control theory in motor control studies. It's just not the case that you have to compute the explicit movement of every part of your limb. Like, you're just falling, and the only thing you need to compute is a limb trajectory such that you can catch yourself as you fall. So examples of this abound. It just doesn't seem to be the case that like you can think of cognition in a kind of disembodied way. So that's
to be explicit, disembodied being like brain in a vat. Just all the sensory input comes in. Or when I say vat, I mean, like a brain up here.
In the extreme view, but also, I mean, you know, a lot of the cognitive science, like Fodor style modularity of the mind, you know, like all these views that say that it's the sandwich model that's being criticized here, right? That like, you know, you passively intake some stimulus, that you construct an internal model, and so it's this internal model thing that the embodied mind people are kind of pushing against. It's like, I don't need an explicit internal model of how every one of my joints moves in space, right? I just don't. I don't need to compute that. My body is such that the only thing that I need to compute is where my leg lands to absorb, like, to keep me from falling, right? But so that's one way that you can understand the embodied mind. Another way that you can understand it is to say that this is a more first-person point of view. It's that like my first-person understanding of the world borrows from my embodied disposition. So think of metaphors like descent into hell or rise to glory or something. Well, that has to do with the way that my body, you know, experiences itself in its lived space, right? So when you're sad, you know, like the entire geometry of your body is kind of like slumpy, you know, like downwards. We associate downwards to disempowerment, and that has to do with the way that we experience space as embodied beings from a first-person point of view. So the last way you might understand it is in terms of like social embodiment. So this is kind of Hegelian. It's this idea that like literally the the layout of our worlds embodies something about our culture. So, you know, like, I'm sure it's, for having been, I know it's the case in Sydney, it's also the case in Montreal, like, you know, our streets meet at right angles. We use things like traffic signals, well, traffic signalization, red lights, all these things that effectively embody norms. I mean, and this is where it kind of connects with the extended mind literature. Like, there's another sense in which the mind is embodied. It's physically realized in these artifacts that embody not just knowledge, but, like, you know, ways of engaging the world that, like, support and ground our coordinated group practices. So this relates to the free energy principle pretty directly. I mean, maybe I should hold off before jumping into that. Yeah.
Was there a final E?
Yes.
I feel like I've
there
just.
is.
Yeah. Okay. Good. Because I'm like, sorry, I'm just too many E's to keep track of.
It's inactive. So,
inactive.
Yeah, inactive means that cognition is something that we do. So, I mean, the idea there is to emphasize, like, the sensory motor loop and to kind of undo the sandwich model. So consider the following, like, what is a visual saccade, right?
Yeah, it's like
action.
Yeah.
Like,
so your point is, like, our eyes aren't static, but they're constantly moving left and right, like very, very small
precisely.
amounts, and that's necessary for vision.
Yeah, it's the mechanism of vision, really. It's like a lot of what your visual cortex is doing in interaction with the motor cortex is kind of deciding where to look next, right? So there's a sense in which the classical sandwich model tells you perception is in the service of action, right? And it's linear. It goes one direction, right? So it's perception, cognition, and then action. And what the inactive approach tells you is, well, actually, action is also for perception. So it's really a loop, you know, like.
It seems like epistemically superior as well, because, like, you learn a lot more from acting than you do from just perceiving. Like,
precisely.
Right, from acting, you get all the information, maybe not all of it, but you get far more than you would if you were just perceiving. Makes me just think of, like,
that's really where the active inference stuff gets its teeth from. Like, active inference is ultimately a theory about how you sample the world. So about how you engage in specific actions that have an epistemic value and that help you disambiguate the world.
So just to make it more understandable, accessible, empowering us to act within it in a way that's hopefully beneficial for ourselves and doesn't result in catastrophe.
Precisely. Yeah. And so out of all of them, I think, like, you can tie all of these E's to the free energy stuff. I mean, we started with the affective.
Yeah.
And I mean, there's a lot of work, you know, from increasingly from our group, but mainly from other groups right now, tying this free energy stuff explicitly into mechanisms of affective processing.
So just a question on free energy. Why is it called free energy? Because my understanding of free energy is, like, energy that is within a system that can be used towards some end. Like,
so heuristically, the way you can think about it is that the variational free energy is a measure of how much wiggle room you have on your parameters still to get a better representational grip on whatever you're trying to represent. So there's a direct analogy in that sense, right? If the thermodynamic free energy is the amount of energy left in the system to perform work, the variational free energy is the amount of energy left in the system to keep doing, like, better representational work. I mean, it's worth mentioning that, like, they are the same quantity in a certain sense. Like, the information-theoretic variational free energy is just a generalization of the thermodynamic free energy.
Okay.
Yeah, I mean, that's where it's a little bit, that's where it gets a little complicated, and that's where like a background in physics is kind of useful. It has to do with these deep relations between probability and energy. So you know, this goes back to like Boltzmann and stuff like that, like statistical mechanics. So like if you think of a volume of matter, right? Like the more energy is in the system, like the hotter it is, like the more possible configurations it could be in. Right? So like if you think of a gas, like, you know, it's very hard to predict where any given molecule of the gas will find itself in the volume. It can move a lot. If you think of a crystal, very regular relations, right? So the notion that we use in that kind of context is entropy, right? So entropy is a measure of spread, essentially. So if you think of a probability distribution, right, over a set of outcomes, right? So like, I don't know, to make it very simple, I'm gonna pull a ball out of a hat, and the ball can be one of 4 colors. I don't know, red, green, blue, purple. Like if I don't know anything at all, you know, about the balls, like that if so there are 4 kinds of balls in our bag, and I'm picking some out. There are not just 4 balls though in the bag. There are like as many as I need. So I want to know something about like the distribution of balls, you know, of ball colors. Well, so if all of them are equally probable, like if in reality there's like 25% of each type, right? Well, the distribution is flat, right? Like because there's 25% of each type. So if you drew a histogram, like it would be a flat distribution, a flat categorical distribution, right? Inversely, if you know, there was only one red, 1 blue, and 1 green, and 97 purple out of 100 balls, then you would have a very peaked distribution, right? Like it would peak over purple, and then it would be very low over the other colors. So the first kind of distribution is not informative, right? Like it's you know, it's equally probable. Everything is flat. We say that the entropy is high in that kind of context because the probability distribution over the system is flat, right? And so there's a lot of spread. Inversely, in the second distribution, the entropy is low because the probability is basically all concentrated over one outcome. So it's very informative. And so you get this kind of behavior in physical systems when you consider heat, right? So a very hot system is high entropy. The specific particles that make up a hot system could be in any number of configurations. A cold system, to the contrary, has a narrower range of states in which it can be. I mean, you can see this literally as water turns into ice, right? Like the degrees of freedom of the parts are drastically diminished as they end up forming a solid, right? So there are these kind of deep relations between the probability of finding the system in a given state and the energy in the state. And so the free energy principle kind of builds on that. I like to say kind of jokingly that it answers the question, how can we be so cool? Meaning that like as living systems, we're in the information theoretic sense, we're very cold systems. Like, so the anthropologist Terence Deacon makes an interesting point. He says, you know, contrary to the received dogma in philosophy, the whole is much less than the sum of its parts. Consider an engine, right? For an engine to work, each of the parts that make up the engine have to be constrained to behave in very specific ways, right? Like you wouldn't want to start introducing degrees of freedom into the piston movement, right? Because you would get some very serious damage done to your system. So like organized systems like engines and humans and bacteria like live in very restricted like subspaces of the possible space of configurations that it could be in. Like, so, in theory, my body temperature could be 50 degrees Celsius or 3 degrees Celsius, but for some reason it maintains itself at 36.5 degrees Celsius. And you could say the same for a lot of the parameters that make up my body. And so the question is, well, how do you manage to stay there? And that's where the free energy principle comes in.
So it's that like organisms, like we are complex adaptive systems, right? Like life is, well, we are, manifestations of, or we are complex adaptive systems. And because we are ordered in such a way, we have a low entropy. I just want to make sure that I'm like communicating this correctly. We have a low entropy because the probability of finding this arrangement of atoms in this state is incredibly low. And that means we have low entropy, right? And what we do is, in order for us to maintain this state across time, based on the fact that the second law of thermodynamics states that entropy is increasing across time, that we need to be taking energy in, processing it in some way to ensure that we maintain this low entropy state across time. And so how does the free energy principle fit into here? Is it, well, so I guess that's where we're getting, right?
Right. Yeah. So the free energy principle tells you what a lot of people don't get about the variational framework is that it all rests on a bit of math. So it doesn't make sense to say, like, is the free energy principle true or false? It's like, well, it's the same status as calculus, right? Yeah. So like, you don't like disprove calculus. Like, if there's a problem with calculus, you derive a contradiction, right? Or you show that this or that kind of bit of the formalism doesn't follow. And the free energy principle is very much the same thing. Like, if we're really just drilling down and like and just looking at it from the most technical point of view, what it's basically telling you is what must necessarily be true of any system that exists at non-equilibrium steady state. So let me unpack that. Equilibrium is the end point, right? So the second law of thermodynamics is about equilibrium, essentially. It's telling you, like, where almost all physical systems are kind of converging towards. So like,
you just think like a hot plate, right? Like one side of the hot plate's hot, the other side's cold. Over time, exactly. The whole plate will be the same temperature. It all goes
it's not just that nature abhors a vacuum, it's that nature abhors a gradient, right? Like nature wants things to be perfectly flat, smooth. So again, it's the entropy thing. It's like nature is trying to flatten all the probability distributions, right? So I'm a big fan of ginger ale. I like a nice cold fizzy ginger ale, but much to my chagrin, if I leave it on the counter for 30 minutes, it'll become room temperature and not fizzy, right? So this kind of room temperature, not fizzy is equilibrium, right? It's just like and if you pushed it to the extreme and I left the thing, I left the glass of ginger ale on the counter for 2 billion years, well, it will have completely dissolved and sublimated into the environment. I mean, like after 2 billion years, like potentially, like even the solid material of the glass would have started to like diffuse into the environment, like through sublimation. There might not even be a glass there left anymore. So one thing to notice about systems in nature is that self-organization itself is almost always in the service of increasing entropy and returning to equilibrium. So that fact is underappreciated, I think, in the study of self-organized complex adaptive systems. So think of a lightning bolt, right? So a lightning bolt arises because you have a charge gradient, right? So like, it because of like the movement of particles and whatnot, like you get more electrons stuck in one place than in another. And in striking the lightning bolt corrects the balance, right? It corrects the imbalance and it brings the system closer to equilibrium. So the same is true of a tornado, right? So you have a temperature gradient in a tornado, typically have very cold and very hot air that kind of meet in a way that they're stacked. And then like the tornado, it looks like it's increasing order locally, and it does locally, but the cost of it is to increase disorder globally. And the same is true of the lightning bolt. The lightning bolt self-organizes around a charge gradient, and in striking it consumes the gradient around which it was self-organized. So this is true of almost every self-organizing system. They increase entropy and they consume energy to stay to self-organize. So if you think of a star, for example,
when you say increase entropy, do you mean locally or do you mean globally? Yeah, because that's the important distinction, right?
Precisely.
So, I was slightly confused because I'm like, no, well, self-organized systems want to stay self-organized and they process or use energy.
Well, I mean, to put it crudely, think of how much matter you have turned into poop over the last year.
Yeah.
I mean, just like think of how much, literally the raw amount of matter that you have disorganized in order to maintain your own integrity. This is the rule. I mean, a star
outputs the rule, right? It's like
exactly. A star outputs a lot of energy, right? Like I mean, all of the energy on planet Earth basically used by living organisms, except in like these weird submarine ecosystems, comes from the sun. But I think the figure is something like it takes 10 times more energy to create a star than a star will output in its whole life. In terms of like the actual energy that it takes to create a star, right? Like,
wow.
Like everything kind of, So even a star is a machine that primarily serves to increase the entropy of the universe. So having said all this, living systems like bunny rabbits and tigers and you and I don't self-organize to equilibrium. We self-organize to this other thing that's known as a non-equilibrium steady state. So the difference is kind of intuitive. Let's take a simple example. My body temperature is 36.5 degrees. My core body temperature, that is. And so that's a steady state. Like my body set that as like a point, and my homeostasis makes sure that I maintain myself at that point. So, I mean, this is contrary to, like I was saying, basically all other kinds of self-organized systems that don't self-organize to this steady state, but rather self-organize to equilibrium. For organisms, equilibrium is death, right? If my core body temperature kind of diffused to room temperature, I would die, like quite literally. So the free energy principle basically tells you what must be true of an organism if it exists at non-equilibrium steady state. And so it's literally starting from information theory and dynamical systems theory, and then like formulating, okay, so like what does the system look like when it exists at non-equilibrium steady state in these regimes, and what must be true of it for it to continue existing in this state. In a nutshell, that's what the free energy principle does.
So how do we begin to, like, there's a few ways I want to go here. One is just describing or explaining how are we sort of measuring these things, or like is this found in all, I guess this is, when you mentioned it's kind of like a tool like calculus, it's not a thing that's observed, it's a way of observing or way of describing these things, right? And this is just something that is a characteristic of life.
So this is where it gets a little subtle. Having said everything about the non-equilibrium steady state, okay, so I didn't tell you what the free energy principle does. I just kind of set up the problem that it answers, right? So to recap, organisms exist at non-equilibrium steady state, right? So now we know what that means, right? So they don't self-organize to equilibrium, which would just, it's my flat and warm room temperature, ginger ale. right? I self-organize to my phenotype. I self-organize to the set of states that I occupy most of the time, right? That make me the kind of creature that I am, right? So if I'm a fish, I self-organize to a set of states that allow me to exist as a fish, right? So I'll grow gills, right, and fins and so on. And you know, analogous things can be said for, you know, self-organization as a human. So given that I exist at non-equilibrium steady state, the free energy principle tells me what must be true of me, you know, provided that I continue existing at non-equilibrium steady state. So in a nutshell, what the free energy principle says is that if I exist at non-equilibrium steady state, it will look as if my behavior is being generated by a statistical model of my environment. So that's the crucial point. It's that it's, are you familiar with Dennett's, Daniel Dennett's, like the intentional stance?
No.
Okay, so it's a position in philosophy that basically says, well, why is it that we are able to treat each other as intentional systems, i.e. as systems that have aboutness, right, that are able to respond adaptively and intelligently to the environment. So Dennett says, well, essentially it's that we adopt the intentional stance. It's not that there's something like intentionality in systems. It's that we for certain purposes adopt towards others a certain perspective that ascribes to them beliefs and desires and so on. And for our survival and insofar as our capacity to explain the behaviors of others is involved, it's adaptive and efficient to do so, right? So this is the so-called intentional stance. So the free energy principle has a similar flavor. It says like, it looks as if organisms, the behavior of organisms is being generated by a statistical model that the organism is. So yeah.
And the statistical model, I really like the idea of, like, I think the most intuitive way for me to think about it is the minimization of surprise, which you could think of as this: if we are a statistical model, as in that we are, like, as you said, it's not just our brains, but our entire being is the model. Then I like this notion of minimizing, of seeing that as a way of minimizing surprise, because surprise is not always good, right? Especially for life. Surprise could be a lion, or it could be disease. It could be anything. It could be.
I mean, in terms of, if you're looking at it like just very technically, the way that it's set up is that like surprising states are not good for the most part.
And we're talking about internal states, but
no, all states.
All states,
like,
yeah.
Yeah.
Okay.
So I mean,
Sure.
Here's where it gets a little subtle, because humans are also averse to boredom, for example, right? So
yeah.
It's not just about making sure that you never are surprised, right? It's just that there are certain kinds of observations about which you don't want to be surprised, right? So like, I currently observe that there's a lot of breathable air around me, right? I'm breathing very freely right now. Similarly, like my observations are consistent with my belief that my core body temperature is 36.5 degrees, that I still have 4 limbs, right? Like there are some beliefs about the typical things that I should be observing that, like, you know, challenging those beliefs is very bad for my survival, right? Like, so if suddenly the first belief that I mentioned, right, that there's a lot of breathable air, was suddenly like put into question by sensing evidence counter to it, I would probably act in a way to make sure that, you know, something different was gonna happen, because I need air. So there's a sense in which, like, the free energy principle builds in like a good part of the normativity involved in existing as a as a prior preference over certain kinds of data or like observable outcomes. Like I prefer to generate certain kinds of data. That doesn't mean though that like I want to eliminate surprise entirely though.
Well, that makes a lot of, I mean, because for one, you can't, and two, surprise is informative, right? And as you go up scale, so this is what I'm very excited about. One of the reasons I wanted to speak in, I think it applies to some of the work that you've done, about how this is found across scales. And that every time, but given that we are embedded and our own actions change the environment, that as we increase, as the scale increases, there is always more to know, and we can always be surprised. And now that we're at this now we are a planetary species, we have a whole host of things to be surprised by now that we wouldn't
there's
be.
A sense in which like this notion of prediction error, it effectively replaces the classical notion of signal. So consider the following, like a 1-to-1 map, like a 1-1 scale map would be completely useless, right?
Yeah.
Like, I mean, imagine like, you're visiting New York for the first time, like a 1-to-1 scale map, like, it would be like bigger than a building, right? Like the actual amount of paper. So like, in order to be useful at all, a model has to be simpler than the data space that it's modeling, right? Like, so there's a sense in which like just by construction for a model to be useful, it will have to generate error. And so in the kind of, and this is slightly broader than active inference and the free energy principle, it's the Bayesian brain with slightly older, approaches developed like in the 90s and 2000s. So like from that point of view, signal, like the signal that the organism perceives is a prediction error. Like, because basically the idea is like if my sensory observations match my expectations, there's no sense in processing it. It's just, it's what I expected, whatever. There's no sense in mobilizing my metabolic resources to address a percept that I had perfectly predicted. And that, if I'm hooked up in the right way, like, predicted percepts should just kind of roll off, without needing to engage them. So there's a sense in which like all signal is error.
And it's efficient that way because and that's what Lisa Feldman Barrett that's what I don't think she discovered, but that's what she spoke about a lot. I kind of forgot about that part of it. That's really interesting.
It underlies a lot of the like the motivation for the approach, right? So we're saying like an organism embodies a statistical model of its environment, meaning that like there's a kind of average value that it expects to encounter for different classes of stimuli, right? And the organism will only be prompted to process like a stimulus when there's a deviation from what it expected. And so there's an extra twist that makes it especially interesting and that makes it robust to some objections. It's known as the darkroom problem. I think it's a non-problem, honestly. But so the darkroom problem says, okay, well, if there's this surprise minimization thing going on, why isn't it the case that I just find a dark room and stay there? Because that would be a great way to avoid all prediction error, right? If I predict that I'm in a dark room and I'm in a dark room, there's no prediction error. And so why don't I just do that? Two reasons I think kind of spring to mind immediately. The first is that you can have so we're embodied, right? To bring it back to the embodied mind, like my body is a statistical model. Like I embody expectations about, my environment. So for example, I have expectations about my blood sugar level, right? And so staying in a dark room with no food is gonna, frustrate some of my expectations about my blood sugar level, such that at some point I'm gonna, move out. There are more direct ways to gerrymander it a bit, and I can see why you might find those like less principled. You could, for example, just stipulate that you have an aversion to encountering no surprise for a while. There's no reason why you couldn't do that. Like just to bake it into, but there's a more principled way to do the same. So this free energy quantity that we've been talking about, what you can do is kind of think about how it evolves in the future. So you can think like, for every possible course of action that I can take, how much free energy is associated with that course of action. So when you have this future-oriented, or this kind of this extended construction of the free energy, it's called the expected free energy. It turns out that for some, using these nice mathematical tricks, you can decompose that into basically a pragmatic component, which is basically how close do I get to my preferred observations, and an epistemic component, which is irrespective of how close I get to my preferred observations, am I gaining any information by making this observation? So like, I don't know, it's 3 in the morning, you come back from the pub, you're hungry, right? You stumble into the kitchen, right? But it's 3 in the morning, so it's dark. The first thing you do is open the light. Well, I mean, from a kind of classical kind of expected utility theory perspective, that's a bit puzzling, because you don't get any immediate gratification from opening the light. You know, it's not like you're getting like, you know, like sexual gratification or like, you know, food stuff immediately from opening the light. But we do though, right? Like, you know, we open the light, and the reason we do is that like there's information gained from doing that. So an action basically has a pragmatic component, the pragmatic affordance or a value of a policy, and the epistemic component of a value or a policy. So another way to respond to this darkroom objection is to say, well, look, like the organism also acts to basically increase its epistemic grip on its world. So there's a point at which like there's nothing more to gain from just like staying in the dark room. And so you'll probably, you know, hear something outside the room and want to disambiguate what that is and go for that. Yeah.
Yeah. I'm curious about what the implications are, or what we know about this and social species, where species have to coexist and collaborate. You know, they can't exist in isolation. They need, like, right. These organisms need to interact and cooperate in order to exist. And I'm thinking of, you know, bees and ants, but also, you know, humans. I've
worked a lot on this. Like that's sort of one of the main thrusts of my research is extending this active inference business to social and cultural behavior. And I guess the main idea there is that these models that I was talking about earlier, these statistical models, so they're called generative models because so technically these models, they are the joint probability distribution over systemic states and external states.
So systemic being the organism.
Yeah, exactly.
Right?
And its internal states, its active states, its sensory states, and some set of external states.
Yeah.
Yeah. So wait, sorry, I lost my idea there.
It's okay. I think I've been there once or twice this conversation. We're talking about social species.
Oh yeah, sorry. Yeah. So these models I was just saying this because they're called generative because of the setup that I was describing earlier, right? You can use these models to generate the kind of data that you would expect if the model was the case, right? So like having a generative model kind of sets you up with, I don't necessarily want to say normative, but like the kind of, it sets you up with like a grip on the kind of typical observations that you would make given the kind of creature that you are, right? So that's literally what it does. It's the joint probability distribution over some external states, right, and some organismic states. So the way that we do cultural and social dynamics under this approach is to say, okay, what happens if several agents share the same model. So again, like the model essentially harnesses your expectations about the way states of the world, which could be social states, hook up to the kind of typical observations that you make, right? So one way to talk about sharing a social world is in terms of sharing a generative model, i.e. sharing a kind of statistical model about how the observations that I make typically map onto states of the world.
And if we were to just translate into everyday language, like people seeing the same phenomena in the same way.
Yeah, exactly. Sharing the same expectations and prior beliefs about the world and about how my sensory phenomenology relates to aspects of the world.
Yeah.
In a nutshell. So, I mean, there's some pretty compelling simulation work done on, it's by Chris Frith and Carl Friston mainly, although it's been extended, on basically little agents. It's like bird song simulation. So you have little agents that sing a song and they're able to coordinate. Like little simulated birds, they're essentially able to coordinate their singing behavior and recognize when they're singing versus when the other bird is singing by sharing the same generative model. Yeah, so I mean, the idea is sort of that if we share the same expectations about the way that states of the world map onto our observations and the way that states of the world evolve, then you know, there's a sense in which each of our individual behaviors end up coordinated because we expect the same outcomes, right? Yeah, so that's how we end up doing.
So it's like I think about it like this: if we're all I don't know, drivers or something, we're all people and we all have a map. If the map is the same, and we're kind of working with other people, we'll kind of go on the same roads, or in some, if we're all following the same map, we'll end up going to the same places. If there's like some sort of directionality, or, you know, X is the spot, I know that I've got a compass, here's the map, I will go in that direction and everyone else will. But if they're not the same, then people might not. That's the...
And yeah, so there's some cool results. This is Eda Bielek, who's currently at UCL. She's done a lot of hyperscanning. Are you familiar with this hyperscanning or social scanning? It's multi-brain neuroimaging. It's like the new thing right now. So like rather than just scan one brain, like in real time, you hook up several people to fMRI or EEG or whatever your modality is, and you can measure brain-to-brain information transfer. Yeah, it's a cool. It's a cool new, a lot of what we're doing now is going to be combining like this hyperscanning setup with active inference models that use multiple agents so that we can,
I mean, are the participants doing things like I first think of like video games, sports, choir, jazz bands?
It depends. I mean, like there's been hyperscanning done on people. The cool thing about some of this hyperscanning stuff using more portable technology is that you can have ecologically realistic settings. So they've used EEG, which are these like caps that pick up scalp electrical activity in operas, for example, to get like people's real-time impressions of like seeing a show together. In this case, it has more to do, I mean, these are techniques, they're used in several different studies. I mentioned Eda's work because she has some cool data where like, it seems that, I mean, this is one of the things that I have to check with her if we can put it on the internet yet. So we might have to cut this out, but this
no worries.
This may just be for your own benefit, but like she has this cool work that shows that basically romantic partners don't attune to each other anymore. They don't have to. Like they're not actively trying to adjust to the other person anymore because they have such an accurate model of the other person. So there's like a sweet spot. There's like
divorce
a sweet
predictions.
spot. If your models are not similar enough, like if you don't speak the same language and you're not from the same culture, there's not enough commonality to start adjusting. But if you're too similar, there's no need to adjust.
Yeah.
So there's like an inverse U curve kind of thing going, where like on the one end, like there's perfect synchrony because you have the same model. So it's like these romantic couples that don't really need to check with each other anymore because they just know. They know what their partner thinks, right?
It's like old people who just don't talk to each other because they're just telecommunicating. Like
exactly. Yeah. So like the kind of overall framework, kind of gives you this inverted U where like it's all about the extent to which you share a generative model. And so I think that kind of well illustrates like this the kind of generalizability of the approach.
I mean, this is a little bit sad, I guess, but be funny to see if it predicted divorce. Like incoherent models. Just like I'm sure they would, right? Because that's how like a lot of divorces arise, right? People acting in one way that doesn't, cohere with what their partner wants, and over time.
Yeah, I mean, so these techniques, I think, are being scaled up to more like interesting, socially rich human behaviors. And so it has to do with the full pipeline. I mean, so I've been talking about like the side of this that I'm like coming from more, which is like the kind of computational modeling side. But I mean, to return to if you don't mind me sharing my screen for a second again.
No, please.
I'll of course describe what's going on. But this is what I wanted. So the full pipeline that we're considering is this kind of thing, where like what I've been talking mainly. So what we're seeing now, for those of you listening, is 3 circles. So you have 2 circles on the side that are pointing towards a middle circle. The middle circle is data. And the 2 side circles are the modeling bit that I've been talking about a lot, and the experimental side of things. I alluded to a bit when we were discussing this Fmri stuff, right? So like, and this relates to our earlier discussion of like, is this an explanation really? Like the full pipeline is this thing here. It's a combination of experimental and modeling techniques that are kind of joined at the data. So basically, you start with either end. So suppose you start with an experimental setup like we were just discussing. Which you have is like people performing a psychological task, and you're getting either neurological or behavioral data or both from them, right? So that's this side of the equation here, right? So you have an experimental setup that generates some data, and then what you can do is write down a generative model of the kind that I just described. Or rather, what you end up doing is writing families of generative models of the kind that I just described, that each represent a hypothesis about the causal structure of what generated, of this process that actually generated my data. So like so in this instance, like each of these models is a model of one possible hypothesis about the causal factors involved in the experimental setup that generated the data in the first place, right? Mm-hmm. So you construct these models, you score them using the variational free energy to find the most probable one, right? And so that model that you end up selecting encodes a hypothesis about the structure of the process involved in the experimental setup. So now what you can do is kind of bootstrap your thing, right? Like you can use the fitted model, right, to make better predictions about what kind of things you would have to test experimentally. So then you can refine your experimental setup and generate better data. And then using this better data, you can construct new models that are more refined and make more pointed hypotheses about the structure of the process that you're investigating. And so you get this cool kind of bootstrapping, like virtuous
reinforcing feedback loop,
science, yeah.
That's really
that's an often underappreciated point. Like I see these kind of partial criticisms of the active inference framework that go, well, you know, like surely these computational models aren't the full story. You know, like you're not really talking about the mechanistic implementation, which is fair. But the thing to keep in mind is that the full framework necessarily includes this neuroimaging aspect that makes very pointed hypotheses about brain structure, for example. Yeah, and in fact, if you think about it, the origins of the approach, you know, are in fMRI. So like the behavioral modeling thing that's kind of become front and center, and that's gained so much attention, actually is just one part of this whole process. I mean, so as a philosopher, the thing that gets me really excited recently is this thing, computational nosology. So this is where we're moving towards a kind of meta science, or a meta-Bayesian meta science. So, I mean, to rehearse the argument, you can have, if you apply this framework to some set of experimental data, like a bold signal, then what you're doing effectively is writing a model of the underlying neurobiological activity that might have caused your data, right? We've discussed this. Active inference takes the same kind of approach and says, okay, here the data are the sensory signals that I generate in engaging with the environment, and the model is a model of me acting in the world. Okay, so what happens when the data that we want to explain is the result of the scientific activity itself? So for example, what happens if the data that I want to explain is a psychiatric diagnosis, right? What I want to explain is the diagnosis of, you know, the actual diagnostic act of, you know, telling a patient you have schizophrenia. Well, then the model becomes a model of the diagnostic process. And then lo and behold, we are part of that model as clinicians and experimenters, right? Like the generative models that we use in this sense, of the active inference sense, right? The models that I bring to bear as a clinician to make sense of the clinical phenomenon presented, right? And also these models, like the models of how like the hemodynamics and so on, like relate
Fmri.
to, yeah, exactly. All of that is now in this kind of meta-Bayesian approach, where like the full model of the diagnostic process includes the models that I use as a theoretician, and the clinical models that are used by like a psychiatrist. So this is where we're going. Like
it seems to me it's just like the scope of what is actually important is far broader. It's not just the actual experiments or the models themselves, but it's those who are actually running them and actually coming up with them.
100%, yeah.
So
yeah,
where's the boundary? Like what is that?
To be one. I mean, so remember that the free energy principle is a theory of non-equilibrium steady state. So if a system exists at non-equilibrium steady state, it can be explained by the free energy principle. This isn't just a hypothesis. By virtue of what it means to exist at non-equilibrium steady state, for principled reasons, you can appeal to the active inference framework, the variational stuff to do it. So to the extent that science is just another, large-scale human activity with its own non-equilibrium steady states, then it can also be modeled.
Yeah, well, this kind of brings me to the point about social systems and all that. And I guess taking this and applying it to our politics and our societies. And I mean, we all have this.
So I'm working right now with my PhD student on the constitution of epistemic communities. So like, it sounds very abstract in one sense, but like, so think of like, you know, you've seen these maps of like the US, like electoral politics and everything, where you have like these little islands of blue and these seas of red, right?
Yeah.
So
we'll close
of the perspective that we're advancing here, I mean, it may be that like people are literally living in different worlds, in the sense that like they're no longer the same kind of creature. They don't have the same generative model. Like just we've effectively the course of politics in, for example, the United States, but I think increasingly elsewhere,
especially, I mean,
like
the information environments in which we're living in are just so like, because we can select what we, through Twitter, Facebook,
Exactly.
these social media environments, we can construct our information environments, and they in turn construct us. And what I think is,
yeah, and that is a beautiful point, and this is one of the things that we've really drilled down on the in the active inference family of things. I mean, you in the discussion before we started, you mentioned Axel Constant, who's a really close friend and a collaborator. And Axel is responsible for also with Jelle Brunenberg, but Axel is like one of the people who's really championed this for the idea that, well, so the active inference formulation is symmetric. I was telling you about this predictability stuff earlier, that like you can predict stuff about the environment given my phenotypic state. Well, that's symmetrical, right? Like you can predict something about the kind of things that live in an environment by looking at the physical structure of the environment. Like the relations of prediction are kind of circular in that way. And certain creatures, like ants and beavers and humans, have evolved such that like we extend our statistical models into the world. Like we augment the physical world with by allowing it to encode information that we can use to guide our behavior. So think of like, the fact that in most big cities, streets meet at right angles isn't accidental, right? It's a feature that we design, right, into the physical layout of our cities to improve our predictive grip on them, essentially, like to make our coping with them smoother. Same goes for like traffic signals and stuff like that. So I mean, there's a sense in which this story opens onto something like, and this is what we're exploring in our current work, like this kind of opens onto a story of epistemic communities and like epistemic niche creation, right? Like we design environments in order to better like to get a better predictive grip on our environments, and that might explain in part like the kind of fragmentation that you see, right? Like that we're literally creating two different kinds of worlds that are embodying two different kinds of, well, outlooks, or we would put it in terms of different generative models. But yeah, this is like a direction that I'm very excited to pursue. Actually, I think there's a lot to say there.
For sure, and when you consider that, so I haven't made it public yet, but I guess it's two articles. One is just on the internet and control, and why how it's a human rights issue, and one is that the internet is just necessary for securing human rights.
Right.
And secondly, we do not, like, our access to it, it is so vital today, but our access to it is actually well, it's under threat at all times. We may not know it, but like it could be taken away from us at any point. And in some places it has been. I mean, China is the greatest example, right, of government censorship. But there's like dozens of countries have stopped social media or like interfered with social media and messaging apps. And when the state, or when privately held interests can effectively dictate what is in one's information environment, they can do a whole range of things, from manufacturing consent to, well, just changing how people think and how they act in the world.
Absolutely.
And I think it's a huge problem, and one that, like, I don't really know what the solution is, because if you take the liberal idea that we should be free to go out and do whatever we want within reason, within certain bounds, but I should be able to expose myself to whatever information I feel like, as long as it's not hurting anyone or anything. If that's actually, if we agree with that, then we can't actually impose these informational constraints, saying that it's all well and good for you to go ahead and do that. However, we need our generative models to be somewhat coherent, or we will conflict.
Yeah, or things just break down.
Yeah.
I mean, like in a really deep way. Yeah, I totally agree. I mean, one huge issue is whose principle is it that it takes an order of magnitude more energy to dispel bullshit than it does to create it?
I'm not sure, but it sounds about right.
It's someone's rule. I forget whose rule it is. But I mean, yeah, that's a real issue, I think. I'm definitely not a liberal. I'm not a conservative either. So I think you can kind of situate me, pretty clearly. I'm sort of grappling with the same kind of issues that you are here. Like I also value freedom of speech and freedom of expression. But on the flip side, like there is something like there's like an ecology of memes, like there's only so much like physical space that ideas can occupy, right? So like
you mean in our minds or like on the net or
but well, on the net and like physically in space as well.
I mean they're technically the same, right? Like I mean the net is an embodiment.
Yeah, exactly.
It is embodied.
So I mean I'm sensitive to that. I'm very worried about like the creation of like these fact resistant bubbles. But like there's a sense in which like I think the current information age exposes a lot of our kind of innate human inherited like evolutionarily old psychology, right? So like what gets called virtue signaling a lot, I think happens both on the left and on the right.
For sure.
I mean, I think ultimately the problem is that like we have forgotten how to engage with ideas, and what takes the place of engagement with ideas is signaling to your in-group, whoever your in-group is, that your values are consonant with theirs.
In my last conversation, we kind of touched on this, and one of the observations that the guest Matthew Pukowski made, which is very very pertinent and true, is that social media kind of it rewards signaling but not action. Like we're all engaged, we're incentivized to just signal great things, right? Or things about our lives or our ideas or whatever, and that signaling is enough. It doesn't really matter if we're going out and doing stuff, and we need to move from signaling to action, especially in this time
like adding a filter to your Facebook picture, to your Facebook
exactly, like
calling it a day, right?
I stand for breast cancer victims, like, oh, you've just saved it, you've solved it. And I think we're all guilty of this. I am myself,
Yeah, absolutely.
And
that's why I'm saying, like, I think it's an issue everywhere. It's an issue. You hear about it a lot because like right-wing pundits accuse like left-wing activists of virtue signaling a lot. But I mean, I think you can see the same essential cognitive strategy redeployed everywhere, essentially. So I mean that's something that's sort of unfortunately predicted by the kind of theory that we're working with.
Oh, really? That's pretty cool.
Yeah, well, because like what we're saying ultimately is that action is in the service of generating evidence for our beliefs, essentially. Right? So like things that conform to our broader generative model. So like it takes a lot more cognitive energy to like confront, observations and data that don't provide evidence for your belief, and to change your belief.
It actually hurts.
I mean, in the literal,
Yeah, and I think it's like, I think of this as like we are constructed we are information, right? Like who we are, the ideas, like the person I think I am is a collection of these ideas that I've kind of brought together and I identify with. And if I find something that that disagrees with them, I am actually being attacked in some way, right? And I think that's where that pain comes from, because it's like there's something about me that is wrong.
It's a lot more complicated because, I mean, left and right, what you're seeing today is a rise of identity-centered politics. I don't want to repeat like, kind of dumb right-wing tropes about identity politics. But it is true that like a lot of the politics that we see today on the left and on the right concern questions essentially relating to identity, right?
Yep.
So, you know,
it's not fruitful. It's not fruitful. As we spoke about earlier, like that you can basically categorize something an infinite number of ways. Some categories are just kind of a bit better at whatever you're trying to do.
So on the one hand, I don't want to compromise, like, you know, activism based on legitimate, you know, like,
the suffering of a particular group and how
exactly,
it's based on, for sure.
Like, you know, denunciations of, you know, forms of oppression that are rooted in, like, I don't know, in the US, like, you know, slavery. Elsewhere, like in you know, histories of colonialism and everything. I mean, you know, as an Australian and a Canadian, we should know a thing or two about, like, colonialism, right? You know, we come from countries where, like, you know, some of the only, like, actually quote unquote successful genocides have been carried out, right?
Foundations of blood.
Yeah, exactly. Where people have been systematically exterminated, like, and we're like, that was carried to completion. I mean, in there are places in Canada where that was carried out against First Nations people, and I mean, you know, there's the actual genocide of the conquering, like all that, and you know, the same thing with in Tasmania where the So, I mean, I don't want to minimize those legitimate airings of, you know, like, or but on the flip side, like, when you make your identity into your thesis, it becomes very dangerous to disagree or to argue about that, you know. So, like, if your main thing is if your main thesis is like, oh, it's something about, you know, American identity, real American patriot or whatever, then it seems to me that, like, you know, disagreement will quickly collapse into, like, you're attacking my identity. Like, my deeply held sense of who I am. So, I mean, I also think it's probably not the most productive way to frame discussions. On the flip side, like, I haven't quite squared the circle of how you recognize that danger on the one hand, and also recognize the legitimacy of identity-based, you know, like, legitimate grievances at the end of the day.
Yeah, it's a tough one. I think one way that kind of definitely doesn't solve the problem, but I think that a lot of this discussion of identity is rooted in inequality and problems of equality. And I think there's too much of a focus on equality in terms of income and wealth, even though it's like a great proxy for well-being and all that. It's just not good enough. Equality of opportunity is something that we should really be focusing on more. And as I said, you know, wealth is a great proxy for that. But if you can't read, it doesn't matter how much money you have, right? You don't have as much access to the world as someone who is literate, or if you have shelter, or if you're adequately nourished, or if you have access to the internet. So by focusing on, I really like the idea of focusing on equality of opportunity and seeing, like, the importance of increasing the landscape of opportunity to people. Because if you think, like, freedom isn't binary, right? Freedom exists in degrees. And if one of the aims of society is to ensure that our citizens are flourishing, one way of ensuring that happens is, like, you make them as free as possible, like increase the landscape of opportunity as much as possible so that they can go and choose to do things. In order to do that, you need to ensure that they have their basic needs taken care of. So, you know, shelter, nutrition, the ability to read, perhaps, all these things increase the landscape of freedom. And then the individual, they know their map of themselves is the best, right? There's nothing better than their internal map of themselves. So they will choose to live a life that maximizes for their own flourishing. So if we wish to ensure that our populations are flourishing, we should kind of increase the degrees of freedom that are made available to them and let them navigate the world.
The unfortunate thing about neoliberalism is that, you know, in the current kind of setup, what freedom means is, like, the freedom to choose between 36 different flavors of ice cream. Right?
Yeah.
Like,
yeah. I think it's just a bit of I don't think we have these conversations widely enough. Like, what is the purpose of society? You know, what is government working towards? Like, what does a good life mean? I mean, I think we might have that conversation around a campfire with a joint, but it's like, we don't hear our politicians actually having these conversations. All I hear is this rhetoric about jobs and growth.
I totally agree. I mean, so I've been setting up an international neuroscience network over the last year or so, and we're really trying to foreground ethical reflection. Because currently, I mean, this whole ethics review board business is basically a box ticking exercise, right? Where like, in science, the way that it basically works is, well, when they were like figuring out like these, the wording of these accords, right? Like the regulate research on humans, then they involved philosophers and everything. But like, it's sort of like they settled everything, like at that point, and now we're not really thinking about like the ethical implications of our research. We're just making sure that no one's going to sue us, which is what the IRBs do. So we've effectively evacuated ethical discussion from like the practice of science, and so yeah, ethics usually means in science like you got a board to review, and it's pretty safe from a legal point of view. Like there's not going to be any like legal blowback.
Yeah.
Well, that's a very, very thin conception of like ethical reflection about the scientific process. I mean, I couldn't agree more with you. Like these things have really been sidelined, like much to everyone's detriment, I think.
Yeah. Yeah. I think we're going to see a resurgence in, ethics, ethical discussions, ethical thinking. I mean, I take that back. Like we already have, it's just like done through the guise of, environmentalism and, like fighting for the biosphere and, humanitarianism. So I take that back. Ethics is still there. We just don't talk about it as ethics. We just appeal to, human nature. But I'm really excited and this is one of the reasons why I wanted to speak to you. And I think will guide a lot of the conversations that I'll have over the next future, but over the coming weeks and months and years. But it's just like, what are the physical characteristics of things that are like, what is the material basis for that which is good? Like if you take,
I mean, well, there's a question. Like,
yeah, well, I think we have like somewhat of an idea, like just intuitively, like systems that are complex. Like there seems to be a correlation between the complexity of a system, however you wish to measure it, and its ethical value, right?
So Axel and I have an ongoing disagreement about this. The disagreement is basically Axel thinks that morality itself can be absorbed under the free energy principle, and I don't necessarily disagree, but I want to push back against that as much as I can. So for the following reason, like, I think that like, what the free energy principle, etc., will tell you is where the system is converging, how it's converging, like what it is converging towards, essentially, right? Like, so to know that doesn't mean that it's a good idea that things are converging in that direction, though.
Yeah. See, that's like this objective, like there is this objective morality that states that thing that you are converging towards is good, right? It's like separate. But I see morality as like, it's actually emergent as well, right? Like I don't think there's
ultimately it may be perspectival. So let's take this account seriously. It sort of implies that morality is embodied in a shared generative model, right? That like has effects in terms of like, allowable cultural practices, allowable ways of like living in a shared environment. But the implication of that is that like, the kind of moral standards are ultimately relative to, the shared generative model. So that like, what do you do then when there are groups of people who come into contact that don't share a generative model? Like, I find it difficult because the scientist in me doesn't see like the possibility of there being like some sort of external way to arbitrate between the sets of. So
it's irreducibly complex, right? And we cannot, like, it's too chaotic. We can't predict any of this. It's not like we can just plug things into a formula and then say, oh, look, this is the more ethical decision. It's just like,
exactly,
it's impossible.
Precisely. I mean, I think you can only find the most likely decision, you know?
Well, I think that's where these heuristics come in, right? Like, thou shalt not kill. Like these 10 commandments are like, they're kind of just like guide rails for humanity, because a lot of, it's really hard to like, I think we've been trying to like figure out what is good. And I think, like these, like the rule-based stuff is just kind of like, oh, we've got a bit of an idea, and like 9 times out of 10 these rules are right. The question of like, I think there is like some material, I think this can be described in terms of energy and information. I'm just not too sure how, but I think it's like, if you were to take a world
that's what Axel ends up saying. I think, I don't want to put words into his mouth, but
yeah,
he ends up saying something like, well, it is about constructing the right generative model. So if we can just like get a picture of what the adequate moral system would look like, and all share this generative model, then we would end up converging to something like a socially acceptable situation.
So I guess this brings me to the last topic I want to cover before we wrap up, and we were kind of speaking about it before, but one of the implications, or like, I guess, logical evolutions of this, just applying of the free energy principle, applying it to humanity, is just like the need for, like, we are a social species. We are engaging at scales that are increasing as the years progress. If we are trying to minimize surprise, for to put it in those terms, then one of the things that we really, really need to do is integrate the sciences into our politics, into our decision making, because like it is truly a matter of survival. And we may be hit with some things that, I mean, they may not be too surprising to some, but COVID, or the array of challenges that we're faced with, which actually threaten not only our survival, but like the survival of lots of life on the planet. Like, what the free energy principle says to me is that we actually need to take these epistemic tools, like science, like these frameworks, these ways of being in the world, and extracting information and putting it to use, and actually making them a part of our culture in a way that's far more embedded and far more, well, I guess, useful than we have
that's the sort
currently.
of ethical imperative that falls out of it. I think what the free energy principle would tell you is that, well, if you don't do this, you're no longer going to exist at non-equilibrium steady state, right? It's just
but that's where we're going. Collapse. That's where we're going. So
yeah, absolutely, 100%.
Yeah.
I mean, the issue is, it again has to do with generative models. It's like the generative models typically have a temporal depth built into them. So basically, like, how many time steps into the future is your model able to model effectively? And I mean, it may just be that like the temporal scales at which we're actually having an effect on the planet don't match up to the temporal depth of the models that we're using to deal with. So like, the time of everyday phenomenology is kind of a cyclical, kind of like 24-hour thing, where like you'll plan maybe a few weeks or months or maybe years ahead. But like there's a mismatch between that scale, right? Like the scale of the generative models that we use effectively in everyday behavior, and the scale of the effects that we're having on the environment. So I think that the political decisions are made with like a 2-year window at most, right? Maybe 4, depending on the country. But like, it's what'll guarantee the next election, So of course there's like this huge incommensurability, right? Like, because the time scales of our practical concerns, and the time scales at which the existential threats to our continued existence as a species, like it's this incommensurability that I think needs to be bridged.
Yeah.
If there's any hope of
Yeah, no, that's a really good point.
That's where I'm cynical. I think, if anything, like this rise of virtue signaling, on the left and on the right, it points to the fact that, like, the kind of disembodied ideal of a rational actor, you know, it isn't really what's at play here. Like people are, I mean, I think was it Isaac Asimov who said, you know, our fundamental predicament is that we have Paleolithic minds, medieval social institutions, and godlike technology, right? Like our minds, like our brains were optimized to handle, you know, it's Dunbar's number, right? It's a niche of about 150 people, time scales. You know, the point of culture in part, the conservative power of culture is to obviate the need to think about long-term regularities in any kind of detail. I mean, that's the point of constructing a niche. You don't have to deal with deep time, because everything that you need to deal with the temporality of the world is already pre-encoded in our practices and in the physical layout of an environment. So like I see no reason to believe that like suddenly we're gonna start shifting our perspective. If anything, I think like, you know, we've constructed like these informational ecologies that make us more resistant to actually, you know, challenging the depth like of the temporal horizon at which we're engaging with phenomena, and rather just like signal to our, you know, our people like us that we're on the right side of history, we're doing this right, and they disagree because they're bad guys. I think that's far more likely that maybe the promise of these meta-Bayesian approaches that I was alluding to is to kind of sketch, you know, some path towards
actually like doing that without, you know, infringing upon people's freedoms. Like if you just look at the US, like they are as freedom loving, and I use that, I say air quotes, because like I think they've got a certain view of freedom that I don't think everyone would agree with. You know, like you are free if you have a gun, you are more free if you have, you know, you can bear arms, or if you don't have your tax, as you'd have to pay as much in taxes because, you know, taxes are theft.
Yeah, I mean,
I think that's
spelled BUMB, right? Like,
yeah. I just hope that, like, I think one of the most important things is, as we said, like taking so we have evolved to exist in smaller tribes, right? But one of the wonderful things is we have developed this capacity to extract really useful information from the world and explain phenomena with it, right? Like science. And our challenge is to like take this, you know, godlike capability and use it with.
Look, I mean, look, just to be a bit like self-critical. So I'm not a climate scientist, right? I'm not, just full stop, right? So like when I say I believe like human-made climate change is real, that's an act of faith on my part.
Yeah.
Right. And so like, yeah, my suspicion is that encapsulates like the human thought process. Like ultimately, like there's something about like deferring to whatever is the default belief of the community that I feel that I belong to. That's like the main mode of operation, even when we think that it yields results that we find are good, right? So, you know, I'm also part of this more like progressive, anti-racist, you know, feminist kind of agenda. But, you know, you might say I'm like this because those are the ideas that are available in my eco niche. I'm just, you know, conforming to whatever is. So I think the person who articulates this most beautifully is Joseph Henrich. I really like Joe. He's great. He's based at Harvard. He's like an evolutionary biologist, anthropologist, and he works on the self-domestication of humans. And so he says, well, basically those very mechanisms that enable us to perform like these large-scale feats of incredible coordination, right? The things that make us like agreeable and able to cooperate with one another are also the things that like, you know, make us susceptible to fascism and to like authoritarian dictatorships, we're agreeable. We just go with things, you know, like the typical Nazi wasn't like a raging fucking racist.
Yeah.
You know, they were just like quote unquote good people, just trying not to rock the boat and just going with whatever and so, you know, that's really what, like, I think it's too easy for us to say like, oh, well, clearly, you know, like we're on the right side of this because our beliefs happen to line up with whatever's the case. In reality, the cognitive operations that I go through to say like, well, you know, I believe in man-made, human-made climate change are essentially the same as like an anti-vaxxer going like, oh, well, you know, like I can't myself verify that this is the case. I don't know the science. Like my opinion rests on this division of labor. And so yeah, so I'm not particularly optimistic.
Yeah, look, I've never thought about it in that way, and you've just made me a little bit more pessimistic. Like I've never really thought about it like that.
I mean,
we are like
what I'm doing is just as faith-based.
Yeah. Because I haven't looked at them. Like I just assume the experts are experts, you know, and just like trust.
But everyone assumes that their experts are experts, right?
Yeah.
That's the thing. That's what sharing a generative model is about.
But at the same time, like there's like that's true. But then when you think about climate change, when you think about that we are on this bounded planet, like, you know, it's a closed system in many ways, and that there's like 8 billion of us. A lot of us are using, I think the number is like 30 times our basal metabolic rate. So like for us to live the lives that we live, we need 30 times the amount of energy our bodies needs. Like when you think about that, it kind of makes sense that things might be heating up. You know, like you don't need to like really
But I'm not denying climate change, of course.
No, I know you're not, but like I don't think you need to be like on this progressive side of things to actually just go through that line of reasoning. Be like,
so like ultimately the big filter is natural selection, right? So we can have the beliefs that we want, and we can have the generative models that we want, but like if we're too off, we're gonna die.
Yeah.
I mean, and that's the bottleneck at the end of the day, and that's also why I'm not super like optimistic, because like the way that these shifts happen typically is massive die-off.
Yeah.
I mean, like that's how generative models end up evolving, right? The same way that everything else ends up evolving. Like, you know, whether it's cultural selection or natural selection, like, you know, the maladaptive beliefs end up like causing negative consequences to their havers and then not spread into the future. And so like, yeah, I agree. Like, you know, I think personally, I think I have good reason to believe in man-made climate change. And I also think I have good reason to think that if we don't take it seriously as a factual matter of affairs, then there will be negative consequences. My fear is just that, like, even if I know this, my mode of justification is not fundamentally different than the one employed by people who believe in chemtrails and, you know, fluoride, gay frog stuff. Like, you know, you heard Alex Jones.
Alex Jones. Did you watch that podcast with him, Joe Rogan, and
no, not the whole
Eddie
thing.
Bravo? Oh, I mean, God. It's ridiculous. It's one of the funniest, most ridiculous.
But fundamentally, though, like the difference is that I have more epistemic tools up my sleeve, right? Like, you know, I'm a scientist. I don't have the exact analytic tools that are used in climate science, but I do know like a bullshit story just pulled out of anecdotes from, you know, rigorous kind of reviews of evidence. But like fundamentally though, like it's all about like the kind of so Joe Henrich calls them creds, credibility enhancing displays. You know, it's that there's an economy of authority. You know, humans are the only mammal species with a prestige system that's evolved independently of the dominance system, right? So like,
what was that system? I just cut out a little.
Prestige.
Ah, okay, prestige.
So prestige is a kind of freely conferred power, right? Whereas like dominance is, you know, you listen to me because I'm going to smack you if you don't, right?
Mm-hmm.
Like prestige is the kind of thing that, like, you know, Joe says, the top climber at the base camp of the Himalaya, right? Like, everyone wants to climb with this person, because it just so happens she's the best, right? She knows how to, you know, go up the mountain. She knows the path. She knows what to do. Like, so
That's
people
socially, but it's like, it's not that she's the best, but it's
freely
socially
conferred.
Yeah.
Right. But there's an economy of authority. Like, in almost every society, there's a series of ritualized cues that indicate who is the knowing caste, right? So, like, you know, scientists wear, you know, saros, and doctors have their stethoscopes, and teachers, profs, I mean, less and less maybe, like, in the North American context, but, like, you know, profs will often dress up. You know, people in positions of power indicate, not just power, but, like, people in positions of epistemic authority reliably indicate with, like, ecologies of cues that they have this authority. And humans are just very sensitive to these cues. You know, it's you know, it's what the Milgram experiments, for example, show. I mean, it's people defer. I mean, I don't know if Milgram still works anymore.
I think it's a bit dodgy.
Yeah, there was a bit of controversy.
Yeah.
But anyway, like, there are these experiments from social psychology that tend to show that people just defer to whatever they think is the source of authority. And I think that's more germane to human cognition than strenuous putting into question of whether this ecology of cues actually reflects something, you know? So I just think it's moral luck at the end of the day. If you and I are on the right side of this kind of factual matter, it's not because of any virtue that we cultivated. We just happen to be in the right epistemic milieu that allows us to make the right kind of inferences. But so my fear, though, is that, like, making these kind of fact-based inferences takes a lot of energy. And there are much fewer people who are able to make them than people who are, like, able to, you know, subscribe on YouTube and start a channel about chemtrails and whatever. So, like, I mean, on the whole, I don't know what's gonna happen. I mean, I don't see any reason to be optimistic. To be blunt.
Oh well, we can do our best and we'll see what happens.
I mean, having said that, like, I think that the kinds of tools that we're developing are giving us a better grip. So, for example, like, you know, this shared generative model business allows us to understand the constitution, right, and the maintenance of epistemic communities in a robust way that might be amenable, we hope, to modeling and to, like, experiment. And so, you know, it may be that, like, by studying the ways in which humans reason, right, and reason on the basis of, like, credibility enhancing displays, right, and arbitrate between different sources of epistemic authority and so on, it may be that, like, you know, through that process, you know,
I hope none of it's age dependent, just because I don't think we have much time.
I mean, it may be. So Rosalind Moran, who's someone that I really admire in the literature, she's a theoretical neuroscientist and neuroimager. She's with the neuroimaging department at King's College. And she has this great model of how basically the parameter range of your generative model becomes more and more rigid as you grow older. And that's not because your brain is, like, deficient, it's that it's adaptive. I mean, presumably when you're middle-aged, you should, assuming, like, a relatively stable structure of the environment, you should have less to learn than someone who's, like, half your age. Yeah. So there is a rigidifying of the generative models that's age dependent. I mean, my own fear has to do with, like, the rapid generational shift. So, like, you know, the boomers that get so maligned in the, you know, just in the media and you know, just abused and everything. Well, they grew up in another world, right? Where, like, you know, journalism was like
well, everyone had the same informational environment, right? Like
right.
you just talk about was on
precisely because there were like three sources of information, right? So whereas people, I don't know exactly how old you are. I'm 31, and so like I grew up with the internet and with the assumption that actually like part of what it is to have a valid epistemic process is to vet, the source of the information where you're getting this. Whereas like if you grew up in an
it's
ecology
intuitive, you just like you look at something and it's like this is bullshit. Like,
yeah, but exactly. But if you grew up in an ecology where there are three sources of information, like the news at 5, your local journal and whatever your big city journal is, like then your relation to sources of information and the very process by which you vet your own beliefs is going to be radically different.
Yeah.
So it may be what we're seeing now may be like and I don't want to make it only into a generational thing. I mean, there are young conspiracy theorists, but it has to do with like, exploiting the basic kind of, mechanisms for attributing epistemic authority. I mean, you'll notice like Trump does this all the time, like he prefaces his sentences with material that would enhance his credibility in certain communities. Right? So saying like, I'm the best at no one understands X better than I do. Like these cues work in a community where typically the people who say this are the people who know. Right? Yep. So if you grew up and you were encultured in a community where, people who signal in this way typically are right about things, then it's not surprising that you'll end up like, adhering to this. And I don't only want to make it into a right-wing thing. I mean, I think...
it's on the both sides, for sure. It's just, we live in such interesting times, well, I think we're just...
The major issue right now is self-righteousness.
Self-righteousness?
On everyone's side. I think it's just, from a philosophical point of view, I come from this tradition called hermeneutics. I mean, my favorite philosopher is this philosopher called Gadamer. Gadamer's philosophy is a philosophy of interpretation. So hermeneutics is sort of a corrective to phenomenology. Phenomenology says, let's start from the first person lived experience and its immediacy. Hermeneutics says there's no such thing as immediate first-person experience. All experience is always already mediated by structures of interpretation. But anyway, I don't want to dwell on that, but I say this because Gadamer says beautifully somewhere, like, the starting point of my philosophy is that my interlocutor could be correct. Right? Like, I might be wrong. It's about interpretation and finding a common interpretation. And I think that's been completely evacuated.
Yeah.
Like, discussion is about showing the other person why they're wrong and showing people on our side why we are so virtuous, right?
Yep.
Like we're really going to stick it to the libs, or just like finger pointing and calling people whatever ism is hot today. Like it's like it's only epistemic. This talk that we're having, this discussion, is only epistemic for show. It's not really about epistemics. It's about confirming what I believe, right? And so telling you who disagree with me that you have to be wrong, ultimately, right? And it's about showing others that we're also valid epistemic agents.
Yeah. I guess like what that makes me think, and I've been thinking for a while, and I'm just echoing what I've heard a lot of other people say, but humility from a scientific standpoint, from the standpoint of policy, but also in our own interactions with each other has never been more important, right? Like that we can learn from the person that we're talking with or arguing with, but also that our actions, like we actually don't know what may happen in the world. We don't know how bad the coronavirus could be. We don't know whether or not our climate change models are actually correct. And given that we do not know, we need to be extra careful, because things could go better than we think, but things could also go a lot worse.
Yeah, precisely. And you know, we have to be open to, and again, I'm not saying that we have to listen to these crazy denialists who you know, cherry pick their data and who are obviously not like engaging in the same kind of scientific process that we are. But like, I especially mean like moral certainties, you know. I mean, it may be that the way that we see the world, even our you know, most deeply cherished values, maybe they're off, you know, to a certain extent. And I think that it's the self-righteousness of everyone involved in these political conversations that makes it. And you know, I'm of many minds about this, because on the same time, you know, at the same time, if someone's position is that like we should exterminate whatever, you know, group of people because of whatever, you know, bullshit reason, then that also doesn't float, you know. Like I don't think that we so it's all sorts of complicated, and I don't have any good answers. I just look at the problem, honestly.
Yeah. Well, that's the first step to solving it, right?
Mm.
Yeah, understanding it.
I mean, the one thing we didn't discuss is what the approach can't do. So yeah, there's good reason to think that nature, you know, life, if life exists, right? If life is a useful concept, if we don't eliminate it from our ontology, there's good reason to think that life isn't a non-equilibrium steady state process.
It isn't.
It isn't. Like so like evolution isn't going anywhere, right? Like life is this open-ended kind of thing that
it's like a tree.
Yeah, exactly.
Yeah.
And it works on a process of drift, which is not predictable, you know. Like, so I mean, natural selection works. There is variation, selection, retention, right? So like that process of is not so the technical term is ergodic. So basically ergodic
so
means
it's the average. Yeah. Like the average is it?
Yeah.
Okay.
So like you know, like, so if you think of the space of all possible states of a system, like an ergodic system means that there's some density towards which the system eventually converges, right? Mm-hmm. Such that on average, so that the average of your measures will converge to a measure of your average.
Yeah.
Because there is a density at the end of the day, right? Yeah. So there's reason to think, and in fact, like I'm working with people who are showing this experimentally, there's reason to think that at several relevant scales, there is a non-equilibrium steady state density. One of the easy demonstrations of this is that I assume, I mean, maybe you have a different physiology from mine, but like you're roughly the same height from day to day, right? Your blood pressure is roughly the same or in the same neighborhood. You know, you have these states that you revisit frequently, you know, such that you can say that there's something like a phenotype, right, that you return to characteristically. But evolution itself is an open-ended process that might not have such a like an endpoint, right? Yeah. So like right now the formulation is in terms of non-equilibrium steady state systems, but it doesn't extend to non-equilibrium non-steady state systems. So
given the time scale, we're not non-steady. So like it depends on your temporal scale then.
Yeah, precisely. There's a scale at which this doesn't apply. Like,
yeah.
And in fact, like it may be that like the more socially interesting stuff that you're interested in can't be addressed by this framework for precisely that reason. Basically, if the attractor doesn't exist yet, there's nothing you can do variationally. Like there's nothing to converge to, right?
Well, sort of, right? I agree. There's no point of convergence. However, one tenet you could say is the need to survive, right? And a part of that is diversity of approaches. So
you can still get something out of it. So you can say like there are something like different attractors that are competing, right? So there's the liberal, the progressive, and the conservative kind of attractors that are sort of competing for where the overall trajectory. That you might say that, but look, like what I want to say is something like, well, you can use the current formulation to model something like feudal France, but not France during like the revolution and the terror, when there just isn't a clear attractor. Like, so the entire approach rests on being able to write down this non-equilibrium steady state density, like the phenotype. If you're able to characterize the phenotype, then you can use this approach to model
the problem, right? Like, life is a process. It's not discrete. It's like we are constantly becoming. I mean, and the way I think about life, and death more specifically, is that we don't really die. Like life is just about information creation, consolidation, and propagation, and we are just passing the baton, right? Like, we live on through our genetic code, but also through the culture, the ideas.
Yeah, precisely. I couldn't agree more. All I'm saying is that, like, and as an advocate of the approach, I also want to hope that there's a way to extend the formalism to non-steady state systems. But if you're asking me, like, what can't this do? Because it does seem like it can do almost everything. Well, so what can't it do? The historical change can't do it right now. Like, I for principled reasons, this isn't like an accident that, like, so, the approach hasn't yet been applied to the formation of epistemic communities. That's not a principled limitation. It's just that it hasn't been done yet. Yeah. So that's what we're doing.
Well, you've got this hammer and there's so many nails now, right?
Exactly. But, like, this may be a principled limitation. It may be that this kind of approach is only conceivable for non-equilibrium steady state systems. And certainly the current mathematical formulation, even in Carl's, like, totally integrative 2020, like, monograph that really contains, like, the whole approach, even there, like, it's formulated in terms of non-equilibrium steady state. So it may be that, like, and this is what's frustrating for me as a scientist, like, maybe the most important questions can't be addressed in this kind of framework, because at least the most ethically important questions, maybe those have to do with when the attractor hasn't consolidated yet. Maybe, I don't know.
Or if there even is one, right? I think that's one of the problems of, like, ethics in general. It's like, well, is there an objective good, and, like, what are we moving towards? And, like, I think in a way it's kind of the wrong question. I don't think there is an objective good. Like, if you take a purely materialist approach, like, we have just, like, minimizing entropy locally and trying to do the best as possible as we move up scales. And when I say we, right, I mean life in general, right? And that morality is emergent. And, like, I think, like, obviously we'd say that, like, that which is more complex, or that, like, life is good. Like, if you think of the world with life or no life, we'd say that life is good. We are obviously biased, but I don't think there's anything wrong there. Like, to say there's no, like, if you take this perspective that we have just kind of emerged from soup and morality has come with it, and that I believe that there would be things that all forms of life, intelligent life, would deem to be of moral worth. So you could think of that as objectively moral, but, like, to see there as being objective morality extricated from life, I don't think that makes any sense.
Yeah, no, I agree, and that's consonant with the framework that we're developing. Since from our vantage point, morality is just encoded in a specific kind of shared generative model,
So my question. So let's say there's two worlds, right? And I know that I have to choose between one, and I've got a flourishing ecosystem, the Amazonian rainforest, or I've got a shitty one, like a desert, right? I just say one of them has to exist. Which one would exist? Everyone would choose the Amazon rainforest one.
Not everyone. If you're a Bedouin, you'll prefer the desert.
Yeah, but I think, like, they are, like, I think on average, and I think the average is important, right? Because it depends on what you're adapted to. Like, I think that we have moral intuitions that point us in the direction of that which promotes order and survival and the increasing of.
Yeah, but here's the rub. Like, that is defined in terms of the non-equilibrium steady state density. So you're still not out of the woods. It's not objective. Like, the good is just defined in terms of, like, what I expect to sense most of the time. And, like, our bodies adapt to this. So I'm a Canadian. Like, When it's 5 degrees Celsius outside, I can go outside in a t-shirt and I'm totally fine. But I don't handle the heat well. When I went to Australia, Jesus Christ, I went in February and Sydney just kicked my ass. I just can't handle this 40-degree heat. So
I lived in Malaysia, right? And I'm like you, I can handle the cold, but the heat just ruins me. So I thought I had a sweating problem, but I just realized I was just in the wrong country.
Well, but your body does adapt. I mean, after several months of this, you do start sweating less. And that's what I mean, though, is it's all about the complete package of priors that you embody. So that there really isn't a way to say, well, this is good and this is bad. I mean, think of a preference for spicy foods. I mean, it's even, or sadomasochism as a sex thing. I mean, it's just the case that there's no objective kind of mapping. It's just whatever is, whatever is available and whatever can lead to a target configuration. I mean, the bit that I kind of skipped over for the social stuff is that what sharing a generative model allows you to do at the end, since you're sharing all your expectations, is to arrive at the same target configuration. So all of these multi-scale models, they rest on the idea that a bunch of components sharing a generative model, if they engage in individual inference, they can still reach this kind of target configuration. So that's how all of this morphogenesis, cellular differentiation stuff in active inference works. And when I met Carl, what made my nose bleed initially was him telling me, the exact same mathematics that we use in the morphogenesis stuff, you could use in the social stuff, because it's sharing a generative model. It's just that in one case, the generative model is a metaphor for a shared genetic and epigenetic code, right? When what you're modeling is cellular differentiation, the genetic code is a shared generative model that tells every cell, well, what kind of thing should you expect to sense given the kind of cell that you are, right? So the very same mathematical framework applies to social dynamics. It's just that rather than what kind of intercellular signaling you're expecting, it's what kind of social cues do I expect to see, right? But it's the same idea. You arrive at a target configuration by sharing a generative model. And the twist for the whole multi-scale story is that this can be reiterated infinitely. So your cells share expectations, but cell networks share expectations, organ networks, organisms, smaller social groups like the family unit, larger social groups like a community. All of these can be cast as successive recursively nested levels of a system that at each level share the same generative model.
And they're all doing the same thing.
Cell, for example, is a cell that doesn't, right? So a cancer cell doesn't have the same generative model as your other cells because its genetic material has been altered, So that's really the perspective from which I'm coming to understand social dynamics. It's also why I'm so pessimistic, to be honest with you. Because I mean, the thing that you see is that you need to share a generative model for there to be a target configuration, right? The shared generative model is what induces the non-equilibrium steady state at the superordinate level. The fact that we all share the same generative model means that our behavior will look as if it's converging towards some kind of phenotype at the higher scale.
So that's how you get self-organization that scales.
Exactly.
Okay.
That's what drew me into the free energy principle initially.
So we need that at a global, at a planetary level now.
Yeah, but then the question is, can we construct a generative model that's both complex enough to capture this kind of, the model is complex enough to capture the complexity of the phenomenon, but also transmissible. One of the big problems that we're having right now in the approach is that this all rests on this high flying. One of the things that people don't get about this is that it builds on quantum mechanics. It builds on classical mechanics. It builds on thermodynamics. So it's much more complicated than quantum mechanics. So there's a transmission issue that gets in the way at some point, because like not everyone can be expected to like assimilate that level of
like that's why I wanted to have this conversation, because like I can like read stuff and understand it, like generally, like not like I'm no genius, but like sometimes I can read stuff and sort of get the picture, but this stuff is a bit impenetrable. Like I don't have a mathematical background. And
yeah, I mean, unfortunately, like the math is required.
Yeah,
it's not like a gloss. It's that like it's sort of like, look, if I ask you, you know, bees make honeycombs, right?
Yeah.
Why are honeycombs shaped the way they are?
Strength and space filling.
Yes, precisely. It's space filling. It's that hexagons are like one of the geometrically optimal ways to tessellate or to completely cover a two-dimensional space. So in this case, it's a bit of math that explains the behavior. Yeah. It's that like you need to appeal to the mathematical fact that hexagons can completely tessellate a 2D surface, and this can be generalized into 3 dimensions, right? Like you need that piece of math to explain the behavior of bees.
So what math do I need to know?
Yeah, I mean, the only way to do that is to like really slowly go through the literature. I mean, I've been doing this, like I've just been doing active inference stuff basically since 2014, and I'm still learning. I mean, like, you know, really it's a multidisciplinary approach. Like there are people from computer science, there are people from physics, there are people from philosophy and from anthropology. And like the full picture is bigger than any one person with their tool set can address.
Well, Maxwell, I think I've taken a decent chunk of your time today. So I guess we'll wrap up. Yeah, it's been lots of fun. If people want to find out about your work, keep up to date with it, where should they go online? How can they find you online?
Well, I mean, I'm on ResearchGate and academia.edu, but all of my research basically, essentially everything I've ever written is available either as a preprint or open access. Actually, the vast majority of my publications are available open access. So I like to say that my hockey card is my Google Scholar account.
Yeah. Well, so I'll link that. I'll link the Twitter account if you want.
Yeah, please. I'm also on Twitter. Twitter's my public kind of academic thing. So like I keep everyone up to date. Like when this is released, I'll advertise it on my Twitter. So yeah, Twitter's the best way to keep like in the loop. But like all of my work is accessible on my Google Scholar account. Like you'll find links to all of the manuscripts for free. So we're really,
that's been wonderful. That's been good. Because I mean, I had to do some research for this, so it's nice to actually. It's nice to be able to access.
It is. I mean, you know, we are definitely not in favor of paywalls and stuff. So yeah, all of my stuff is accessible. So
yeah.
Thank you for the invitation. Honestly, Sam, this has been very, very enjoyable. And,
it's been good fun. It's been good fun. Thanks for taking the time, and I'm sure we'll do it again sometime soon. Yeah, I'd love to. Whenever you want me back, it was really a pleasure. So awesome.
Let's do it again.